So in today's class, we're going to be solve the section 4, 7th question first. Solution. Find the derivative of y equals to x cube plus y equals to x cube plus e raised to 3x plus sine 3x minus 4 log x. Let's try to differentiate with respect to it. Differentiating with respect to x to equation. Let me consider equation. So dy by dx equals to dx plus d by dx e raised to 3x plus d of x sine 3x minus d by dx 4 log x. Here note d by dx x raised to n gives n minus 1. We know that d by dx x raised to n equals to n into x raised to n minus 1. This is the general formula. So here where n is nothing but here 3. So 3 x raised to 2 here plus differentiation of e raised to x is e raised to x itself. So here differentiation of e raised to 3x is e raised to 3x. So we need to apply here chain rule. 3x plus differentiation of sin x is cos x. So cos 3x. Again we need to apply chain rule minus 4 as a constant. Differentiation of log x equals to 1 by x. So this will be 4 by x. 3x square plus e raised to 3x. Differentiation of 3x is 3 plus cos 3x. Differentiation of 3x is 3 minus 4 divided by x. So here finally we'll get 3x square plus 3 into e raised to 3x plus 3 into cos 3x minus 4 divided by x. This is our final answer. Next problem. Let y equals to 1 plus cos x divided by 1 minus cos x. Here differentiating with respect to x to equation 1. Let us consider equation 1, this one. So here dy by dx 1 plus cos x divided by 1 minus cos x. Here we know quotient rule here. As per the quotient rule says y equals to u by v. After differentiating we will get here v square v into du by dx minus u into dv by dx. Now let's try to use the formula here. 1 minus cos x whole square 1 minus cos x d by dx
1 plus cos x here, again minus 1 plus cos x, differentiation of 1 minus cos x. Let's try to solve the further here. 1 minus cos x whole square, 1 minus cos x. So we know that d by dx cos x equals to minus sin x. So here differentiation of 1 is 0 here. So differentiation of 1 is 0 and differentiation of cos x is minus sin x minus 1 plus cos x. Differentiation of 1 is 0, again minus differentiation of cos is minus sin x here. 1 minus cos x whole square, 1 minus cos x minus sin x minus 1 plus cos x, minus into minus plus, so we will get sin x here. 1 minus cos x whole square, 1 minus cos x sin x minus 1 plus cos x sin x here. So here this will be minus. Let's try to multiply here. Minus sin x, minus into minus plus sin x cos x minus, again here also sin x plus into minus sin x into cos x whole divided by 1 minus cos x whole square here. So here plus sin x cos x minus sin x cos x will get cancelled here. So minus 2 sin x whole divided by 1 minus cos x whole square is our final answer. Next problem. Find dy by dx for y equals to e raised to sin x plus sin x cube plus tan x. So y equals to e raised to sin x plus sin x cube plus tan x. Differentiation of e raised to x is ex itself. Differentiation of sin x is cos x. Differentiation of tan x equals to secant square x. Differentiation of x raised to n equals to n into x raised to n minus 1. Now let's try to solve. Differentiating, let us consider equation 1. Differentiating with respect to x to equation 1 here. So we'll get dy by dx e raised to sin x plus d by dx sin x cube plus d by dx tan x. So after applying differentiation, we'll get here e raised to sin x. Again we need to apply here chain rule. So this will be differentiation of sin x plus differentiation of sin x is cos x cube x. Again we need to apply chain rule here, plus differentiation of tan is secant square x. So here e raised to sin x, differentiation of sin is
cos x plus cos x cube x. Differentiation of x cube is 3x square plus secant square x. So after rearranging we will get e raised to sin x into cos x plus 3x square into cos x cube x plus secant square x. This is our final answer. Next problem. S equals to t square plus 60 plus 5 represent the displacement of the particle in motion at the time t. Find the velocity of the particle and acceleration at t equals to 3 seconds. Let's try to find out what are the data given in the question, where S represents your displacement, t square plus 60 plus 5 here at t equals to 3 seconds. We need to find out the velocity value as well as acceleration value. We know that velocity is nothing but change in displacement divided by change in time. So here d by dt, we know the value of s. S is nothing but t square plus 60 plus 5 here. Let's try to differentiate here. Differentiation of t square is 2t plus 6. So here v equals to ds by dt at t equals to 3 seconds. Let's try to substitute the value of t, where t is nothing but here 3 seconds. 2 into 3 plus 6. 2 3s are 6 plus 6, which is equals to 12 meter per second. Always the velocity measures in meter per second. So here v equals to 12 meter per second. Now let's try to solve acceleration here. A represents acceleration. The definition of acceleration, change in velocity and change in time, I can say, or else we can write d square by s divided by dt square here. So somehow we know the value of v here. V is nothing but 2t plus 6 here, d by dt 2t plus 6 here. Differentiation of 2t is 2 itself. So we got acceleration value. Acceleration value always measured in terms of meter per square second here. So acceleration is 2 meter square second. Next problem. Y equals to e raised to x sin x. Here we need to find out the value of dy by dx. We know that product rule here. As per the product rule says d by dx u into v, u dy by dx dv by dx plus v du by dx. As per the question here, y equals to e raised to x sin x, where ex is u into v is nothing but here sin x. So let's try to substitute the value of u as well as v in the given formula. So dy by dx e raised to x dy dx sin x plus sin x d by dx e raised to x. E raised to x, differentiation of sin is cos x. Here sin x, again e raised to, differentiation of e raised to x is e raised to x itself. So here we can take e raised to x as a constant outside. So cos x plus sin x. This is our dy by dy x y.
Next problem, y equals to tan inverse 1 plus x divided by 1 minus x. So here we need to find out dy by dx. Note, we know that differentiation of tan inverse x equals to 1 divided by 1 plus x square here. Again, d by dx u by v, which is equals to v square v du by dx minus u constant, again dv by dx. This is the quotient rule. Now let's try to solve the problem by using the formulas here. Equation 1, differentiating with respect to x here to equation 1. So we will get here dy by dx equals to 1 divided by 1 plus x minus 1 minus x whole square into d by dx 1 plus x minus 1 minus x. So here we can simplify further, which will give 1 minus x whole square plus 1 plus x whole square 1 minus x whole square into here quotient rule. So we will get 1 minus x whole square 1 minus x differentiation of 1 plus x minus 1 plus x differentiation of 1 minus x. So here 1 minus x whole square plus 1 plus x whole square 1 minus x whole square into 1 minus x whole square 1 minus x. Differentiation of 1 is 0 and differentiation of x is 1 here minus 1 plus x, this is constant. Again differentiation of 1 is 0, differentiation of x is 1 here minus 1 because it's a minus x here. 1 minus x whole square divided by 1 plus 1 minus x square plus 1 plus x whole square into 1 minus x minus into minus, which will give plus here 1 plus x divided by 1 minus x whole square. 1 minus x whole square 1 minus x whole square will get cancelled here. So finally we will get 1 minus x plus 1 plus x whole divided by 1 minus x whole square plus 1 plus x whole square. So further we can simplify here. 1 minus x, we can open the brackets, minus x plus x will get cancelled, 1 minus x whole square plus 1 minus 1 plus x whole square. So finally we'll get here 2 divided by 1 minus x whole square plus 1 minus 1 plus x whole square.
Next question. Find the equation of the tangent to the curve y equals to x cube at the point 1 comma 2 here. given data. Here we need to find out the value equation of the tangent to the curve here. So given values are x equals y equals to x cube at 1 comma 2. Here we need to find out the equation of the tangent to the curve, which is given by y minus y1 equals to m into x minus x1 here. Before that, we need to find out the slope of the tangent. Slope of the tangent, which is nothing but dy by dx, or I can say m. So here, first of all, we'll try to find out the value of dy by dx. Let us consider y equals to x cube here. Equation 1, differentiating with respect to x to equation 1 here. So dy by dx, which gives 3x square here at the point 1 comma 2. At 1 comma 2, I can say. Let's try to substitute the value of x here. 3 into 1 whole square, which gives 3. So here dy by dx at 1 comma 2, or m, the slope of the tangent, which is 3 here. So here y minus 2, m is nothing but 3, x minus 1 here, y minus 2, 3 into x, 3x minus 3. So after simplification, we'll get the equation of the tangent here. Dx minus 3 minus y plus 2 here equals to 0. So 3x minus y minus 3 plus 2 gives minus 1 equals to 0. So we can say the equation of the tangent is 3x minus y minus 1 equals to 0. Next problem. Y equals to tan inverse x. Here we need to show 1 plus x square y2 plus 2x y1 equals to 0. Let me consider equation 1 here. Differentiating with respect to x to equation 1 here. So dy by dx, differentiation of tan inverse is 1 plus x square. So dy by dx, differentiation of tan inverse gives 1 by 1 plus x square. So this equation can be further rewritten as 1 plus x square dy by dx equals to 1 here. Here we can use the product rule, d by dx u into v here, u dv by dx plus v du by dx. Let me consider equation 2 here. Again, differentiating with respect to x to equation 2 here. After differentiating equation 2 again here, 1 plus x square d square by dx square plus dy by dx into 2x equals to 0 here, where dy by dx equals to y1 d square by y dx square equals to y2 we can see. So we have 1 plus x square. This will be y2 plus y1 into 2x equals to 0. After rearranging 1 plus x square into y2 plus 2x square 2x y1 equals to 0. Next problem, integrate solution I equals to integration of x square plus sin x plus 1 by x plus e raised to 2x here, hold with differentiation dx. Note, integration of x raised to n equals to x raised to n plus 1 divided by n plus 1. Integration of sin x equals to minus cos x plus c. Integration of 1 by x equals to log x plus c, as well as integration of e raised to x equals to e raised to a x divided by a plus c. So by using these formula we can calculate the problem here. Let's try to make a separate all the terms here. Integration x square dx plus integration sin x dx plus integration 1 by x dx plus integration e raised to 2x dx here. So here x raised to 2 plus 1 divided by 2 plus 1 plus integration of sin x is minus cos x plus integration of 1 by x is log x plus integration of e raised to 2x is e raised to 2x divided by 2 plus c. At the end of the solution we need to be add the c value as a integration constant here. So here x raised to 3 divided by 3 minus cos x plus log x plus e raised to 2x divided by 2 plus c. This is our final answer. Next problem, that I equals to integration of 0 to pi by 2 here cos square x dx here. We know that cos square x equals to 1 plus cos 2x divided by 2 here. So here we can substitute cos square x equals to 1 plus cos 2x divided by 2 here. So 0 pi by 2. Here cos square can be rewritten as 1 plus cos 2x divided by 2 dx here. So here we can split into two parts, 1 by 2 plus cos 2x divided by 2 dx equals to integration 0 to pi by 2 dx by 2 plus integration 0 pi by 2 cos 2x divided by 2 dx. So here after differentiating we'll get x by 2 pi by 2 0 plus again here also 1 by 2 as a constant outside. So after differentiating we'll get here sin 2x divided by 2 pi by 2 0. So 1 by 2
pi by 2 minus 0 plus this will be 1 by 4. These two will also come as a constant outside. So here sine 2 pi by 2 minus sine 2 into 0 here. 2 get cancelled. So here we'll get pi by 4 plus this 1 by 4, 0 minus 0. So pi by 4 plus 0. So finally we'll get here pi by 4 as an answer. Next problem, I equals to integration of x into e raised to x dx here. So it's in the form of u into v itself. So here we know that integration of f of x into g of x dx equals to f of x integration of g of x minus integration of g of x dx differentiation of f of x again whole dx. So here we can see f of x is nothing but x and g of x is nothing but e raised to x. Let's try to substitute all the values in the formula and try to simplify the problem here. X integration of e raised to x dx minus integration of e raised to x dx differentiation of x whole term we need to be considered here dx x here integration of e raised to x is e raised to x itself minus integration of e raised to x is e raised to x and differentiation of x is 1 dx. So here x into e raised to x minus integration of e raised to x dx here ex into ex e raised to x minus integration of e raised to x is e raised to x itself plus c. Here at last we need to be add plus c because it's a integration constant. So finally we'll get here x into e raised to x minus e raised to x plus c. Let's try to solve the next problem here. Y equals to x square plus 3. X equals to 1 and x equals to 2 as given in the question. So let I equals to integration of x1 x2 y dx equals to integration of 1 to 2 limits. So here y value is x square plus 3 here. So x square plus 3 dx. So here we can integrate x cube by 3x whole square. So limits here 2 1. Let we can substitute the limits here. So 2 cube divided by 3 plus 3 into 2 minus 1 cube divided by 3 plus 3 into 1
So here 2 cube is 8 here, divided by 3 plus 6 minus 1 divided by 3 plus 3. So here we can take LCM 3. 8 plus 18. Here also we can take LCM 1 plus 9 here. 3 into 3, 9 here. So here we can add 8 plus 18, 26 divided by 3 minus 1 plus 9, 10 divided by 3. So further here we can take LCM as a 3 here. 26 minus 10, which gives 16 divided by 3. So we know that area of the bounded curve A equals to 16 divided by 3. A equals to 16 by 3 square units here. Square unit is the unit of the area of the curve here. Next problem, let I equals to integration 1 to 2 1 divided by x dx here. So integration of 1 by x dx equals to log x we know. So log x, here limits are 2 1. So we can substitute the value of x here. We can substitute the limits here. Log 2 minus log 1. We know that log 1 is 0. So here log 2 minus log 0. We know that log 2 minus 0. So we'll get log 2. I equals to log 2 is our answer. Next problem, integration of, let's I equals to integration of tan inverse x divided by 1 plus x square dx here. Let us consider theta equals to tan inverse x. Equation 1, differentiating with respect to x here, so we will get d theta by dx equals to differentiation of tan inverse x is 1 divided by 1 plus x square here, so we will get 1 divided by 1 plus x square. So here d theta equals to dx divided by 1 plus x square here. So here we can say I equals to integration where theta equals to tan inverse, so we can substitute here theta into, as well as d theta is nothing but dx divided by 1 plus x square here, dx divided by 1 plus x square. So value is d theta. So here integration of theta is theta square divided by 2 plus c. So somehow we know the value of theta here. Theta value is tan inverse x whole square divided by 2 plus c. So this is our final solution.
Next problem, that I equals to integration x into secant square x dx here. It is in the form of u into v here. So we need to be use the formula. The formula is given by integration of f of x into g of x dx equals to f of x, which is constant here, integration g of x dx minus integration of g of x dx into f dash of x. F dash of x is nothing but differentiation of f of x dx here. Now let's try to substitute the values of f of x as well as g of x. This is f of x and this is g of x. So here we can substitute the values here. X into integration of secant square x dx minus integration of again secant square x dx, differentiation of here x into t of x. So here x into integration of secant square x gives tan x minus integration of again here integration of secant square x gives tan x, differentiation of d by dx which gives 1 here into dx here. So here x into tan x minus integration of tan x dx which gives log secant x plus c here. So here we can substitute here log secant x plus c here. So which is our final answer.
Next problem. Find the volume of a solid generated by revolving the curve y equals to under root of x square plus 1 between x equals to 0 and x equals to 2 here. Given data, y equals to under root of x square plus 1. So this can be further rewritten as y square equals to x square plus 1. V naught equals to integration of x1 x2 by y square dx here, where x1 as well as x2 value are 0 as well as 2 here. So here integration 0 to 2 pi we can take as a constant outside. Y square value is x square plus 1 dx here. Now let's try to integrate here. Integration of so after integrating we get x cube divided by 3 plus x. So here we can substitute the limits here. 2 raised to cube divided by 3 plus 2 minus again 0 cube divided by 3 plus 0. So here let's try to simplify. So 8 by 3 plus 2 here minus 0 by 3 plus 0. So here pi. So here we can take LCM 3. 8 plus 6. The complete term will be here 0 pi 8 plus 6 14 divided by 3. So finally we'll get here 14 pi divided by 3.
cubic units.